Once we have understood that 1 mole represents 6.023 into 10 to the power 23 entities of any given type, we also note that the molar mass or the molecular mass is going to represent the mass of 1 mole of that particular molecule. So let us say let us take the water molecule. This is H2O. How many protons essentially are present in H2O? Electron compared to the proton is very light, and hence we can ignore the mass of the electron. So how many protons are there over here? There are 2 protons in the 2 hydrogens, and there are 8 protons in oxygen, and there are 8 neutrons as well. So the 8 neutrons that are present in oxygen have to be considered as equivalent in weight compared to the protons. Thus, total we would have an effective 16 plus 2, that is equal to 18 protons. Now we know that 6.023 into 10 to the power 23 protons weigh 1 gram, meaning any number of protons, Na into mass of the proton, this we know is 1 gram. And here we have got 18 equivalent entities. So 18 entities that are exactly like the proton in mass are going to weigh 18 into Na into the mass of a proton. Here we have approximated the mass of the neutron to be the same as the mass of the proton because those two values are very close by. So 18 into Na into the mass of the proton is going to be equal to 18 grams. Thus, we understand that 1 mole of H2O molecules essentially weighs 18 grams, and this quantity 18 grams is considered as the molecular weight of H2O. Similarly, let's take O2. O2 has effectively 16 protons and 16 neutrons, and thus 1 mole of O2 is going to be equivalent to 32 effective protons into Na. So that's going to be equal to 32 grams for 1 mole of O2, and thus the molecular weight of O2 would be considered as 32 grams. Now hereby we get a simple template in order to figure out and find out the molecular mass or the molecular weight of any particular substance. Let's take carbon 12. So for carbon 12 or the normal carbon, we have one carbon 12 atom consists of 6 protons and 6 neutrons, and thus 1 mole of carbon 12 atoms would consist of 6 into Na protons and 6 into Na neutrons. So this is going to weigh overall 12 grams because it has got 12 entities that effectively have a molar mass of 1 gram each. Thus, this 12 gram is constituted of 6 protons plus 6 neutrons into Avogadro number. So the mass of 6 protons and the mass of 6 neutrons into the Avogadro number Na is going to lead to 12 grams, and thus the molecular mass of carbon 12 is 12 grams. Now let us say if we were to find the number of moles present in 12 grams of H2. What do? We know that 1 mole of H2, 1 mole of H2 is going to be equivalent to 2 grams because the molecular weight of H2 happens to be 2. Thus, 12 grams of H2, this is just ratio and proportion now. Okay, so 12 grams of H2 is going to be 12 grams divided by 2 grams per mole because 1 mole of H2 weighs 2 grams. So this is going to be equal to 6 moles. So if we see what are we doing essentially, we are using an implicit formula which says that number of moles is equal to weight of the substance that has been given in grams divided by the molecular weight, which is usually expressed in grams. So this is what we have used over here as well, and let me highlight this particular formula so that it is apparent and should be noted. Let's go ahead on to further examples. Let us say 2 grams of hydrogen atoms. How many moles would 2 grams of hydrogen atom constitute? So here number of moles is equal to weight upon molecular weight. So the molecular weight of hydrogen happens to be 1 gram. So the answer is going to be 2 divided by 1 is equal to 2 moles. Let us take 4 gram of helium. Helium is the first inert gas, and the helium nucleus consists of 2 protons and 2 neutrons, and thus the molecular weight of helium is going to be equal to 4 grams. So since we have taken 4 grams of helium, N is going to be equal to weight upon molecular weight, that is equal to 4 divided by 4. I'm not writing the grams for simplicity, and thus this is 1 mole of helium atoms. Let's go ahead. Let's look at urea. Urea is an important biological compound. This is the molecular formula for urea. Now let's calculate the molecular weight of urea. We simply do it by adding the atomic weights of the various atoms present. Carbon is going to have an atomic weight of 12. The two nitrogens are going to have an atomic weight of 14 each. So together they have a combined atomic weight of 28. Oxygen is going to have an atomic weight of 16, and there are 4 hydrogens present. So the 4 hydrogens have an atomic weight of 4. Thus 16 plus 4 is 20, and 12 plus 28 is 40. 40 plus 20 is going to give me 60 grams. Thus urea has a molecular weight of 60 grams per mole. So 1 mole of urea is 60 grams of urea. So in this example, let us take 180 grams of urea. We have been asked to find out the number of moles in 180 grams of urea. Very simple. N is equal to weight divided by molecular weight. So the weight of urea over here is 180 grams. So 180 grams divided by 60 grams per mole. This is going to give me the answer as 3 moles. Let's go ahead. Let us take 24 milligrams. We have taken 24 milligrams of O3. Ozone is an important gas that is present in our atmosphere that prevents us all from getting cancer because of the carcinogenic radiations from the sun. So it happens to be an important gas, and we have taken here 24 milligrams of O3. What is the molecular weight of O3? Molecular weight of O3 is 3 times the atomic weight of oxygen. That is 3 times 16 is equal to 48. And we have taken 24 milligrams of O3. And the question is to find the number of moles in 24 milligrams of O3. Number of moles is weight upon molecular weight, or it can also be said to be mass upon molecular mass. So the mass that we have taken is 24 into 10 raised to minus 3 grams. That is what 24 milligrams represent. So this is 24 into 10 raised to minus 3 divided by 48. So this is nothing but half into 10 raised to minus 3 is equal to 0.5 into 10 raised to minus 3. That is equal to 0.5 millimoles. Let us take another example. Let's say we have taken 1.6 kgs of SO2. What is the molecular weight of SO2? It is 64. I'll leave the calculation to the student how it is 64. So the molecular weight of SO2 happens to be 64. It's very simple. Sulfur is 32 and the two oxygens are going to be 16 plus 16. So 32 plus 16 plus 16 is going to give you 64. Okay. So when we take 1.6 kgs of SO2, how many moles do we have? N is equal to weight upon molecular weight. So this is going to be 1.6 into 10 raised to 3. Remember, we have to convert everything into grams. So this is 1.6 into 10 raised to 3 divided by 64. So this is going to be equal to 16 into 10 raised to 2 divided by 64. We know that 16 ones are 16 and 16 fours are 64. So this is going to be 100 divided by 4, and thus the answer is going to be 25 moles. Thus 1.6 kgs of SO2 gas comes out to be equivalent to 25 moles of SO2. These were some examples wherein we calculated the number of moles from the mass given, and we understood the essential basic concept of what the mole is.